In this video, we're going to take a look at bar charts, histograms, and box plots and consider how they can be used as part of the data preparation phase of machine learning. So first of all, why bar charts and histograms? It lets us take a look at a value across several columns of data. Typically, these will be features or things that we would use to try to predict a target. Another thing that we can do is take a look, with a histogram, take a look at the distribution of data across categories. So does it follow a normal distribution, or does it follow some other type of distribution that we might need to transform? So for this example, I'm going to take a look at some car sales data that I grabbed from Kaggle. I've started a notebook with the imports that we're going to need. Now we can read in our car sales data, and we confirm that we're able to see a bit of data here. I'd like to do a scatter plot on this, but there's quite a bit of data here, about 24,000 rows, so I'm going to filter it by only data in this very first month, which would be January of 2022. And then we'll do a scatter plot based on income and the selling price of the vehicle. I'll start with just the filter to confirm it gives me what I expect. So carSalesDF, and then we put our filter in the square brackets here, and we're saying date is less than 1/31/2022, and we see 585 rows, which feels like a good amount that we could plot. So now let's add a plot to this. We'll simply use that data set, or the filter data set as it is, and then attach .plot.scatter, and then X will be our X-axis variable or column, and Y naturally will be the Y-axis, what the column we use for the Y-axis. Now what we see here is interesting. Remember, we're not only looking at plotting, but we're considering how to use plotting and graphing to make better decision models. And what we see here in the month of January is a bunch of dots with zero income who are buying cars anywhere from $10,000 to $80,000. And you think, okay, wait a minute. Maybe I didn't consider that. Maybe I didn't consider somebody without income buying a car, much less a more expensive car. But then I think about my grandfather, who was a pharmacist in Clifton for basically an entire career, raised a family of 6 children, and was very thrifty when he raised his family of 6 children, tended to make things last a very long time. Then he retired and his children were grown, and he bought a Cadillac. So he had zero income, but after a life of savings, he, bought a Cadillac, and every time, I was probably one of his last grandchildren to be born, so the whole time I knew him, I always knew Grandpa driving a Cadillac. So we think, okay, that is one category of customers, those who are either retired or maybe a student or something like that, where either they have savings or somebody has gifted them money to buy a car. And we see that they will buy, what they purchase is a reflection of what everybody else purchases. So where everyone else is buying $10,000 to $30,000 cars, that's where we see a whole lot of concentration down here in the zero income group. So I would consider modeling that one separately if we're doing some kind of regression analysis, or if we're doing unsupervised learning, I would consider this to be a distinct group, the zero income group. And then we can take a look at this other group and say, okay, is there any need to subdivide that one as well? And we know the scatter plot will show us one variable versus another variable, and then put dots on the plot that represent one dot for each row. But we're only really looking at 2 variables here. So I've added a little snippet here that is going to look at 2 different variables. It's going to look at income versus price. And instead of having in this case, we're saying that automatic cars are blue and manual transmission cars are orange. So this is a bit interesting because we see that at most values, we have a good mix of automatic and manual transmission. But then once we get up to the higher values, it's more manual transmission. And we see that not a whole lot of dependence on income for that, which is interesting. When I think back when I was just before driving age and looking at cars, I remember that automatic versus manual transmission made a significant difference in the price of the car. And back in that era, in the 1980s and 1990s, there were a lot of stick shifts, a lot of manual transmissions. Now, manual transmissions tend to be for enthusiasts. People who really like driving a stick shift, frankly, as I do, and prefer to drive a stick shift, but it doesn't necessarily make the car less expensive. So I think in the 80s you would have seen low income tend to prefer manual, where high income would prefer automatic. Now I think you don't see that much variation. As a matter of fact, many times to get a manual transmission you have to pay more, or it has to be a specialty type of car. But nonetheless, we see that by adding color we can actually consider 3 groupings of variable in our scatter plot. Now, one little cleanup I'm going to do, we notice that this kind of some inconsistent column names here. We have car underscore ID, but then customer space name, annual space income, dealer underscore name, and then price with a $sign. I'd like to go ahead and clean up those columns, make them a little bit easier to refer to. So I'll do our carSalesDF.rename, and then inside of that columns, and effectively pass a dictionary of existing name to new name for each of those. Each of those I'm reducing to 1 word so there won't be any spaces. And then we print out and see, okay, we do have a bit of a cleaner data set now. Now we can take a look at some of these columns and create some bar charts. Now I have a rule when I'm doing an example around data mining where I tend to not use any demographic information. I want the lesson here to be on how to do data mining for business intelligence. What I don't want you to come away with is me saying something like men tend to buy this and women tend to buy this, or something of that nature. So I tend to avoid those when I'm doing examples. In this case, I did an average price paid for cars by men and women, just curious. And it actually came out to be almost identical. So this one I'm going to go ahead and bend the rule a little bit and go ahead and group by gender. So to create a bar price of average price paid by female and male, we'll need to start with that group by. Note group by, 1 word, no underscore or anything else, all lowercase. I'm simply grouping by the gender column and then pulling out the price and then asking for the average price. So group by gender, price, and then average that by gender, and then say plot, and simply say that we want to make it a bar plot, and set a Y label for price. And we see, sure enough here, male and female, not a significant difference in the price that they paid. Now let's do this analysis again, but let's look at the make of the car, which here is called company. And here we see, okay, we do see a bit more variation here. We see that Cadillac tends to have a higher selling price. Hyundai tends to have a lower selling price on average. Volvo, Volkswagen right in the middle. So not a big surprise here, but the manufacturer has, is a significant influence on that sale price. Naturally, some cars are going to be considered luxury cars, where others are going to be considered economy cars. And in some cases, we can break that down by manufacturer. Let's do the same comparison again, but this time look at dealer name. We see here that by dealer, the prices are roughly the same. So a couple considerations on that. If these were new cars, then I think the dealer might have a bit more influence on the price, because dealer tends to be associated with a make or a brand or a company, if you wish. So a BMW dealer is going to have higher sale prices than, say, a Hyundai dealer for new cars. The trick there, when we're considering machine learning, is that it might be too tightly correlated. So if we find there's a very strong correlation between dealer name and company, then we don't want both of those features in a regression model, because they might cause some misguidance in that model. We don't want to have 2 very closely correlated columns. We only need 1. Because that 1 can help us to predict the outcome. So that's a caution I would normally have here, is look for tight correlation between 2 things if we see them. On the other hand, if these are used cars, the dealer name probably wouldn't have as much to do with it, because the used car market is not tied to the primary brand or primary banner on that dealer's sign. Now, there could be some variation based on the neighborhood. Is this in a more affluent neighborhood where people are looking for nicer, higher-end cars? Or is it maybe a neighborhood where people are looking for something to get by for a couple of years, but not looking for a status symbol? So there could be, if we look at that, then we say, okay, this is an independent variable. What I would likely do to make sure is do a scatter plot on prices based on both company and dealer name and see if we see any correlation, or just do a correlation matrix on that, see what that turns up. Color. I've often heard that color is a determining factor in the price of a car, which is kind of funny because that could be chosen at the time of manufacture, right? But you never know. Maybe color, maybe some seasonality. So we see color, a little bit of variation, but not a whole lot. So with this now, let's take a look at a histogram of price. And a histogram is going to help us see the distribution. Is it a normal distribution like a bell curve distribution? Is it a triangular distribution or something else? And will that distribution impact how we pre-process the data before we model the data? So for a histogram, again, just a couple lines. So note that we're simply accessing our data frame and then calling the column where we want to invoke a histogram, and then saying hist. And then we set our labels as price and count. And you can see the distribution we have here. Not perfectly normal because we see it's a little bit front loaded to the left, but there again, that's not a big surprise because a car usually won't sell for less than $0. And there aren't many cars that would sell for less than, say, maybe $3,000. At that point, you're pretty much going to scrap it. But a lot of car sales we see are going to be in that $10,000, $20,000, even $30,000 range. And then we have the exotic cars way out on the fringe. So we could possibly look at this and determine a shape. It almost feels like an exponent in reverse, where an exponent would normally be a curve going up. This looks like almost an exponent in reverse. So maybe some things we could consider out of that, along with our grander consideration of all the data we're looking at. And while we're talking about distributions, the box plot is a really handy graph because it shows us effectively the median, or the 50% mark within our data set. Also the bottom quartile to the top quartile. In other words, it'll show us where 25% of the records fall below and above, then where 50% fall below and above, 75 below and above, then 100%. And then it shows us outliers as well. So a really good graph for looking at both the distribution and outliers. And once again, this one's just a few lines to put together. I simply take the data frame and then attach box plot and tell them what the two values I want to look at. In this case, it's going to be by price and by company. So I'd like to render this and then show you a couple of the options that I used here and also how to read it. So if we take a look, say, at Mercury, this one has a very wide distribution. You see the 0 quartile starts here. So this, from where my mouse is now up to where the box starts, that's effectively the lowest 25% in sales. And then 25 to the median is this little section right here, effectively this first box. So if we go from median down to this line, that's the first 50% of sales. And then the box starts where 25% of sales. And by percent, I mean 25% of sales were below this number, which looks like about maybe 19,000, and 75% of sales were greater than this number. So then we have the median line, about maybe 22,000. It means 50% of sales were for less than that amount, 50% of sales were for greater than that amount. Then we come up here to the top 75%. So the top of the box says, okay, everything under here, this is where the bottom 75% of sales numbers were in this stretch here, and the top number were here. So from the box to the top of the line, that's the top 25% of sales dollars for Mercury. Now, if we look at some of the others, we'll see there are a similar box, but then we have kind of circles up above. And the circle says, well, we think these are outliers. So we went ahead and put this box together, but it makes a lot of sense if we take out these outliers. So this is a really handy way to look at the distribution, see how wide it is, how big the box is, see how close the bottom 25% is to the entire range, but it's also good for spotting outliers. Another thing that's helpful here when we're analyzing this is that the line that separates the box is the median. So in other words, when we sort records from sales highest to lowest, when we find the record right in the middle, what is that sales dollar? That's the median. It's not the mean, which is the average of all sales prices. Comparing the median to the mean can give us an idea of how skewed our data are. If they're fairly close, the data are probably not very skewed, but if they tend to be far apart, we may be dealing with some skewed data that requires some additional transformation. And that's a look at box plots and histograms and a bit of scatter diagrams and how we can use them in data mining. I hope this video is helpful, and I look forward to reading your comments. Thank you.